Please subscribe, follow and like engineeringall.com.
Synthetic leather, often referred to as fox leather or artificial leather, has emerged as a revolutionary solution in a world grappling with sustainability concerns. This comprehensive exploration delves into the intricate and fascinating process by which synthetic leather is made, from the initial stages of substrate creation to the final touches that mimic the texture and appearance of genuine leather. This journey reveals the innovation, technology, and creativity that makes synthetic leather a versatile and eco-friendly alternative. Introduction: the rise of synthetic leather. In an era defined by heightened environmental consciousness, the production of leather has come under scrutiny due to its association with livestock farming and resource-intensive tanning processes. In response, synthetic leather has risen as a compelling alternative that offers the look and feel of genuine leather while reducing the ecological footprint associated with traditional leather production. The manufacturing process of synthetic leather is a testament to the marriage of science, technology, and creativity in creating a sustainable and versatile material. Step 1. Substrate creation. The intricate process of creating synthetic leather commences with the formation of a substrate, a foundational layer upon which the material will be constructed. Common substrates include fabrics made from polyester, nylon, or other synthetic fibers. The choice of substrate material depends on the intended application of the synthetic leather, with considerations such as durability, texture, and compatibility playing pivotal roles. Step 2. Coating application. The substrate undergoes a sequence of coating applications that imbue it with the appearance and texture of genuine leather. These coatings are formulated using polyurethane, PU, or polyvinyl chloride, PVC, resins, additives, and colorants. The coating process serves several crucial functions. 1. Binder layer. The initial coating acts as a binder, bonding the fibers of the substrate together and providing a uniform surface for subsequent layers. 2. Texture layer. Additional coatings are applied to replicate the texture of natural leather. Advanced embossing techniques and specialized molds create intricate patterns on the surface of the material, mirroring the grains and textures found in genuine leather. 3. Color and finish. Colorants are introduced to achieve the desired hue of the synthetic leather. Clear coatings are layered on to provide a protective finish, enhancing the material's durability and imitating the natural sheen of leather. Step 3. Embossing and texture creation. Achieving the distinct texture of leather is a critical step in the process. Synthetic leather undergoes embossing, wherein specialized rollers or molds imprint patterns onto the material's surface. These patterns range from classic leather grain to more elaborate and intricate designs. This step is essential to ensure that the synthetic leather not only looks authentic, but also replicates the tactile sensation associated with genuine leather. Step 4. Finishing touches. The material then undergoes a series of finishing processes to refine its appearance and performance. 1. Buffing. Buffing removes excess material and creates a smooth, consistent surface. This process is instrumental in ensuring that the synthetic leather's texture closely resembles that of natural leather. 2. Color application. The meticulous application of color follows, involving careful attention to achieve the desired hue, depth, and shading variations characteristic of genuine leather. 3. Top coating. A final layer of protective top coat is applied to safeguard the synthetic leather from wear, UV radiation, and moisture. This layer also imparts a subtle sheen, closely replicating the luster of authentic leather. Step 5. Inspection and quality control. Stringent quality control measures are implemented throughout the process to ensure that each batch of synthetic leather meets stringent industry standards. Thickness, texture, color consistency, and durability are meticulously assessed, and any deviations from the desired outcome are rectified before the final product is deemed ready for distribution. Applications and sustainability. The applications of synthetic leather are as diverse as the industries it serves, including fashion accessories, upholstery, automotive interiors, and beyond. Beyond its aesthetic appeal, The sustainability aspect of synthetic leather is a driving force behind its popularity. Unlike traditional leather production, which involves resource-intensive processes and livestock farming, synthetic leather is created through fewer steps, reducing its environmental impact. The journey of crafting synthetic leather is a synergy of technology, craftsmanship, and eco-consciousness. By ingeniously replicating the appearance, texture, and some functional attributes of genuine leather, synthetic leather provides consumers with a guilt-free option. As the manufacturing process continues to evolve, refining techniques and pushing the boundaries of what is achievable, the role of synthetic leather in shaping a more sustainable future for the fashion and interior design industries becomes increasingly prominent. The fusion of innovation and ecological responsibility has given rise to a material that not only meets consumer demands, but also addresses pressing global concerns, making synthetic leather a pivotal player in the journey towards a greener and more stylish world.
Thank you for watching. Please hit the red button to subscribe for more videos.